In the second part of this parabola bit, it's the third on functions, or graphs, whichever you want to. But we're going to look at moving the parabola, because some of the types of questions they ask you, okay, and that's what I'm focusing on. They say, given this parabola, draw it, or whatever the case might be, or the equation of the parabola is this. And what is the equation if we move the parabola 5 units down and 4 units to the left, right? What you have to do is you have to reconstitute that parabola's equation from the old one. So what are we doing? Essentially, we're going to have a parabola there, and we're going to move it across and down, or we're going to have a parabola over here, and we're going to move it across and down, or from here to there, whatever the case might be. I think you get the general gist of what we're after here and what we're going to be doing. So all of this, okay, all of the moving a parabola, it's not only a parabola, it's the others also. Moving a parabola, you use the turning point, okay, which is P and Q, is it not, from the thing? Because if you remember, okay, moving something up or down, let's just recap. Moving up or down affected Q, which was the Y coordinate, didn't it? Moving it down or moving it up affected Q, right? Then, because we had the turning point formula, we had Y is equal to A, X minus P plus Q, all squared. I often forget that. My bad if I do. Please forgive me. It's just, when you're doing it on here, it's you're trying to be a little more efficient and quick, and sometimes it drops off the wagon. So what have we got here? This was the X and the Y. Now, if I move up or down, it affects this one, doesn't it? The Y and the Q. It affects that way. Okay. All right. What happens if we move to the left or the right? We're affecting the X coordinate. Let's just look at that on the side here. We've got a X and a Y. Let us say that point there is 3 and 5. All right. Now we're going to move, here's the instruction, move A, this is A, 6 down and 8 to the left. What are you going to do? Then we want to find the new coordinates. Let me use red. So we're going to move this how much? This is going to be 8. All right. So the new X is going to be equal to 3 minus 8 minus 5. And where are we moving Y? Moving Y down 6. So the new Y is going to be 5 minus 6, which is minus 1. So therefore, my new coordinates, my new coords is going to be what? New coordinates is minus 5 minus 1. Okay? You actually go to the coordinates and you go and count them. And if we move a parabola, we do the same thing. What do? We take it and we move it up or down. So we find the turning point number 1. Let's just put it here. Moving a parabola. The question you will be asked is, given a parabola, we move it we move it to the right and down, or to the left and up. Okay, what's the new equation? So step 1, find the turning point. Then move that by the amount stipulated. Okay? In other words, you take the x and the y and you apply change to find new x new and y new. Okay? So we're just moving one point, all right? That is, this is the new coordinates of the turning point, isn't it? We've applied the change to the turning point, so it is the new turning point. And subs into y is equal to a x minus p plus q squared. So you put your, this is p, q, you put him in there, and you put him in, sorry, my bad. Oop. You put him into, okay, him into here, and this guy goes there. All right, that's quite fancy. So that's what we're going to do. Okay, I'm going to make another sheet. Right, we've moved the parabola left and right, up and down. It doesn't matter what we're going to do. All right, here let's just do an example. That's the easiest way to do these. Okay, the example of this is given the parabola y is equal to, it doesn't matter, minus 3, x minus 3 all squared plus 5, right? That's a parabola, right? And what is the equation of the new parabola if we move it right? Now they say 5 left, 5 to the left, and 7 down. Right, step 1. Okay, step 1 is going to be find turning point on existing parabola. Okay, find the turning point on the existing parabola. In this case, it is going to be P and Q. I don't need to manipulate because it is a minus there. So P is 3 and 5. Now, they have told us that we're going to move it 5 left, right? 5 to the left, okay, and 7 down. So therefore, new turning point coordinates are going to be, let's look, it's at 3 and 5. Okay, like this, isn't it? So that is 5, this is 3. So we said we are going 5 to the left, right? So we're going this way, okay, 5. So the new one is minus 5, which is minus 2. Just count. 1, 2, 3, 4, 5. That's moved. This point has now moved to minus 2. And the y coordinate has moved down. 5 has gone down by 7. So it becomes, and we end up with minus 2. Right? So the new coordinates of the turning point are, let's just move up a little bit. New coordinates are going to be minus 2, minus 2. Then you back substitute that into the turning point formula. Y is equal to, and I think we had a minus 3 times x minus P, Q, X, Y. P is minus 2. Remember, back substitute into the standard form. Let me rewrite this. Okay, I want you to be 100% sure. TP now back subs new TP coords into standard formula. Okay, standard formula, and we write it down. Y is equal to A x minus P all squared plus Q. A hasn't changed. A doesn't change. A still stays, in this case, I think I called it minus 3. A stays at minus 3. I haven't made it any different. X minus, and P is minus 2 all squared plus Q is minus 2, which means it's minus 3x plus 2 all squared minus 2. This is the new graph. All right? This is the new graph. Okay? Now, obviously, if you're asked to sketch the graph of, I don't know, let's say y is equal to minus 2x squared plus 3x plus 9, what you would do is you would do exactly the same, wouldn't you? You'd put x, you do shape, it's that way. You do x, you do let x equal 0, let y equal 0. The turning point on here, you would say x is equal to minus b over 2a, which is minus 3 over 2 times minus 2. So that's going to be minus 3 over minus 4, which is going to be equal to 3/4. And then back subs into there to find y. Okay, then you'd say, in other words, you'd factorize it, you'd let y equal 0, x equals 0, and you'd find the turning point using the formula minus b over 2a. Okay, you wouldn't go and complete the square on that. All right. Let us say they ask us to find the equation of a parabola. This is finding the equation. Oops, that's quite dreadful. That's even worse. Finding the equation of a parabola. Okay. Now, there's a couple of things here. They can either give us they give us a graph or coords. Okay, so they can give us A, B, C's coordinates, and they can tell us what they are or not, and they give us a graph to work from. What do we have to do? Okay, we have to, in all these cases, we look for a clue. The clues are roots given. Then you would use the root equation. Y is equal to a, x minus r1, x minus r2. Okay. B, turning point. Then we'd use y is equal to a, x minus p plus q. All right. And if we're not given anything, you'd use, y equals ax squared plus bx plus c. Okay? So obviously you've got to read. It's hidden in the language of all of these. Okay? In order to answer, you need to know which type, and then you apply the formula for that type. Even if you don't, you're going to get the same answer. The difference is it takes a long way around to get it. Okay? Let's say, for example, we have to this. Okay? So the recipe is this. Recipe number 1. Turning point given. Use TP formula. Y is equal to A, x minus P all squared, plus Q, and subs the x and the y for P and the Q of the turning point. Right? Then solve for A by substituting the other point, the other given point. They are all going to be the same. Okay? Other given point, and I'm going to actually put in here to find A. Okay? That does look like a 9, doesn't it? To find A. Okay? Okay, let's have a look. Let's go through the recipe for the next ones, shall we? The next one is or given the roots. Okay, you use like this. Let's say the roots given are -3 and 0. And 3 and 0. You notice, aha, roots. Because why? Y is 0. So it must be lying on this axis here, correct? Because y is 0. So the roots, you have to look for the clues. Right? Then we substitute, you use the root formula. A, x minus r1, x minus r2. And you'd go a, x minus r1 is x minus -3, okay, and x minus 3, and that's going to be x plus 3, x minus 3, and essentially you'd multiply that out, okay, substitute into it, and you'd multiply it out, and use third. Let me just use the third given point. Okay, come on. Use the third given point to find A. How do you do it? Okay, you back sub the coordinates x third point, y third point. In other words, the non-roots, you'd put x in there and you'd put y over there and solve for A in front there. Sorry, that A looks like a 9 again, doesn't it? Right? Can you see? It's the same thing. All right. Okay. The last is if you are given 3 points, okay, not root nor turning point. Okay, right. Subs the points into y equals ax squared plus bx plus c. You will find one of the points is 0 and y. This is the y-intercept, which is what? It's C. But if you plug it in, you will see that you will be given 0 there. So that would be 0, that would be 0, and you'd have your y there, and you'd get C. Okay. The next step is then substitute, okay, remaining points x and y, and we always get 2 simultaneous equations. Solve. Okay? To get A and B. Right. We're going to do examples. Now, all of these, please, just before I go on, you can either give it as or be given it as coords, A, B, C, or a graph. All right. Now, if you're given a graph, obviously that point, that, you know that those would be the roots, that would be that, or the turning point, right? In other words, you'd read off the graph. It's much easier. You'd read off the graph. You'd read your coordinates in that you would actually back substitute into your equations, wouldn't you? So I'm going to just give you the coordinates in a blurb, all right, in a language, right? Let's have a look. Example. Okay, let's just do this. Example. Find the equation. Find the equation. The equation of the parabola. Whoops, hang on, stop. In B. They've told us what the graph is because you're going to get one that says straight line, parabola, hyperbola, exponential. Find the equation of the parabola going through A, minus 1 and 16, and B, 2 and minus 20. Given A, that A is the turning point. Cool. Next bit of information. There it is, turning point. Okay, so we know to use the turning point. And they then say, to confuse you, your answer must be in the form y equals ax squared plus bx plus c. They're telling you your answer must be in that form. They're actually being quite nasty here because they're trying to trick you. Okay, but at this level, you know what? They really do expect you to think about it. So you say, okay, hang on. They've told me it's a parabola. They've told me turning point. Step 1, standard form. Y equals ax minus p all squared plus q. I chose that because why? That's the turning point one, isn't it? And they've told me use the turning point one. Right. So what do? I put in the figures that I've got. I then say the turning point, TP, that I've been given is minus 1 and 16, correct? So I substitute in y is equal to a times x minus 1 all squared plus 16, which is a times x plus 1 all squared plus 16. NB. When you put that in, remember, I know we've said it a dozen times, when you're putting it in, remember to put your P in as negative, it changes to positive. Okay, so we've got that. Then what do we say next? Next we say, okay, well, I know that. The recipe said, then put in the next point. Step 2. Subs in other given point. Okay, so therefore, y, they told me, y is going to be what? Minus 20 equals a times, and they've given me x. X is 2 plus 1 all squared, and it's plus 16. Okay, here we go. Now I multiply this out, and I get minus 20 is equal to a times 3 squared plus 16. Do a little bit of rearrangement, and you get a equals minus 4. Therefore, y is minus 4x plus 1. all squared plus 16. They want it in the generic format. So what do I have to do? I have to multiply it out, group-like terms, and I get y is equal to minus 4 times x squared plus 2x plus 1 minus 16. And if you work it out, you're going to get minus 4x squared minus 8x plus 12. Can I divide through by 4? No. Okay. Quite a number of students have said yes, but can I simplify it? No. You can't divide. Why not? Because it's equal to y. It's not equal to 0. If it's equal to 0, you can simplify. No simplifying. Okay, please leave it as that. All right, let's do another example. Take a different one. Here's an example here. Okay, given A of 8 and 0 and B 4 and 0 and C 1 and 42. Okay, find the equation of the parabola. Of the parabola. Okay, note, no turning point given. So it's not a turning point one. So now I look and I see, okay, what are A and B? Well, let's try and plot this. A is 8 and 0. 8 and 0, look. And the other's 4 and 0. And the turning point is at 1, okay, and 42. All right? Something like that. 42. Oh, well, we'll have a look now. Okay. You can see it's a root 1. Okay. No, it's not the turning point. Another point is at 1 and 42. Okay, right, cool. So let's go, and now what do? We go and we plug it in. They've given us that y is equal to x minus r1, x minus r2. Okay? All right. I think it's 1 and 42. I think I made a mistake there. Doesn't really matter. We say, okay, y is equal to that. Then we say, right, plug in what we know. A times x minus, and in this case, it's 4. X minus 8, which is going to be equal to a times, and multiply it out, okay? And we're going to get, if you wish, all right? You don't need to multiply it out, all right? Okay? You don't need to multiply it out. Then, next step, subs the x and the y of the remaining point into the formula and solve for A. Okay, I've got 1 and 42. That doesn't look, well, let's put it in. Yeah, it can be. It's right up top. Okay, you just pull you down a bit. All right. What have we got? Okay, so we then have got y is equal to a times x minus 4, x minus 8. And the point I'm subsing, the point is 1 and 42. Right? Let me just try. I wished I had a neat handwriting. 1 and 42. Therefore, I say y. Well, hang on. I've got y. Y is equal to 42. Oops. Therefore, 42. Can you see what I'm doing here? I'm substituting that in there and the 1 in for the x's, right? So let's continue. 42 is equal to a times 1 minus 4 times 1 minus 8. And I'll work this out, and I get that's going to be equal to 21a. Therefore, A is going to be equal to 2. Therefore, it's going to be equal to y is equal to 2 times x minus 4, x minus 8. Multiply that lot out. Please don't multiply in and so just multiply it out. Minus 12x plus 4 8s are 32. And the final answer is going to be 2x squared minus 24x plus 64. No simplifying. Okay, no simplifying in that case. Okay, the last one I'm going to do here. Okay, I've gone over, I'm sorry. All right, we say the last example, okay, is given a parabola. Given a parabola goes through A, B, and C with coordinates, right, as follows: -1, 9, 0, and 8. Remember, anything with a 0 needs further investigation. -2 and 8. Where is that point? Find it. It is at 0 and it is C. What did I say? Plug in. Well, y is equal to ax squared plus bx plus c. Let's put it in. 8 is equal to 0 plus c. C is equal to 8. You can read it straight off, okay? So therefore, what do I say? I say this is going to be 2 simultaneous. So I then say, right, point A is going to be -1 and 9. And point B is going to be -2 and 8. And these I tend to do as follows. I then say my standard form is y is equal to ax squared plus bx plus 8. Y is equal to ax squared plus bx plus 8. Now we're going to put in for each one the x and the y. Okay? So let's put in the x and the y in each case. Over here we substitute in that one and we get this. 9 is equal to a times, 9 is equal to a times -1 squared plus b times -1 plus 8. And we end up with 1 is equal to a minus b. Okay, if you multiply all that lot out. Okay. The next one, we plug it into this side and we say 8 is equal to a times -2 squared plus b times -2 plus 8. Guys, why am I doing the brackets? Remember, we say when we substitute in, use brackets every time. Okay? They're the safety belts. They're going to prevent a mistake with the negative, which is going to sink us. Okay? So therefore, I write that down and I end up with 2a minus b equals 0. And then all I do is I go ahead and solve. A is going to be equal to -1. B becomes equal to -2. Therefore, my graph is -x squared minus 2x plus 8. I have gone over. I do apologize for that. I wanted to get to the end. That is a substitution. Please go through that one again. And it's really your skill there is, first of all, you just look and see, hang on, I wasn't given a turning point, no roots. Just always have a quick plot. Put them somewhere. You'll see, whenever you see a coordinate that's a 0, that's a giveaway to investigate that coordinate a bit further. Guys, we're going to do hyperbola next time. Thanks for watching. Have a great time. Good luck with these. Just do a few practices, follow the recipe blindly, and the answer pops out by itself. Cheers. Bye.